Within the Synopsis trends, we're going to talk more specifically about the band power trend analyzer and the power ratio trend analyzer. And we'll talk about the technical details, some clinical applications, and some examples. So we'll start with the band power analyzer. The band power analyzer is a measure of power over a specific selected frequency. So you actually choose which frequencies you're interested in. Well, it's thought to be less susceptible to artifact because you actually narrow down the frequencies of interest so you can exclude those that you know have artifact in them. And it's thought to be somewhat useful for identifying seizure activity. Now, it defaults to the 5 to 15 hertz range, so you will need to tweak it a little bit and adjust it for the patients that you're looking at. If we look at band power, it's not quite like the envelope where we are getting a measure of all of the activity in particular waveform. We're actually breaking it down into the different frequencies. So we're going to look at 3 different segments of EEG. Segment 1 is mostly alpha range activity with a FFT peak in about the 10 hertz range. And from the FFT, we can generate a bar graph showing the percentage of power at each frequency band. So we have a large vertical bar, the green bar, from the alpha, and a much smaller one, the red one, for the delta range activity. In segment 2, there's alpha dropout, and you see increased delta. So 2 peaks emerge in the FFT, corresponding to changes in the FFT spectrum and in the larger vertical delta bar and the smaller alpha bar. And then finally in segment 3, we see almost no alpha and significant amounts of delta range activity, which is reflected in both the frequency spectra and the vertical band power bar. So for this, what I've done is I've broken out the different frequency bands. And as we stack this up, we get a time sequence of the alpha power bands. We could also do a time sequence of the delta power bands. The band power is calculated based on a defined band of frequencies. So you choose what band of frequencies you want to use. As I mentioned before, the default is 5 to 15 hertz, which may not be optimal for many situations. If you're interested in the calculations in general, this information is available in our help files in the software under the question mark, the help files. Using band power for seizure activity is one of the potential applications. So if you look at the 3 per second spike and wave that we are seeing on the screen, you can see that the cursor placed next to the band power trend identifies that peak. There are several other peaks, and that allows you to count through and get a good idea during this period of time of how many peaks there are. Now, the things that you can change in the band power include the stop and start frequency, the input type, whether it's bipolar or referential, which active electrodes you're using, and the time window. Always important to look at the time window because that helps you differentiate and spread out the waveforms so that you can see them better. Now, band power example. Now, this is the patient we saw in the previous example, and you can see that what the patient has is periodic episodes. I'm going to place my cursor over here on the trends, and you can see that as we approach some of these peaks, you will see the events. Now the way I have this spread out, you will see the corresponding EEG before it actually hits the peak. And often when I'm on the peak, we have actually passed the event. Now, I don't find the band power trend to be the ideal trend for identifying seizure type events, but it's another tool in your arsenal.